So this is what you guys have. You've got heads or tails. If I did a heads, then what could happen for my dice?
1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, 6. Good. Okay. Did you catch this part before? Were you here today or not? Okay. Yeah. So next lesson is okay. Yeah. Hold on a second. Let me just go through this.
So away until 7:30.
Yeah. All right. So this is what yours should look like, right? This is your sample space. Tail on a 3, tail on a 4, tail on a 5, tail on a 6. Let me show you something else real quick. You can also find the probabilities. So this is how you draw a probability tree. You write the probability for each event on the actual branch. Right? So the end is the destination. And I might even block out this part here. I might block out that part there. I'm not worried about that. But along the way, you have all these other things happening. You have, like if I wanted to end up at this spot here, 1/2 chance of rolling a heads, 1/6 chance of rolling a 4. So then this would be, the beauty of these is you just multiply along the branches. So to get to this spot here, I would just take these numbers and multiply them. So here is my example. I flip a coin and roll a dice. I want to find the probability of getting a head on the coin and a 4 on the dice. They're independent events, right? We determined that already. Right? Flipping a coin and rolling a dice, they have nothing to do with each other. Do we all agree those are independent? So, probability of head and a 4. Remember, that means that both things happened. And means both things happened. You rolled a head you flipped a heads and you rolled a 4. So it's probability of heads times probability of 4. Probability of heads, 1/2, times probability of 4, 1/6. When you multiply fractions, you multiply the numerators and you multiply the denominators. So multiplying a fraction, this would be 1 times 1, 2 times 6, your denominator would be 12. So just multiply the tops, multiply the bottoms. Good? Just as a refresher, so you guys, it's been a while since you multiplied fractions. You can also solve it using sample space. Right here's the sample space. Heads and 4 is 1 out of 12, 1/12. But like I said also, you can just multiply these things along here. So 1/2 chance of heads, 1/6 chance of 4, 1/2 times 1/6. 1 times 1 is 1, 2 times 6 is 12. Good? All right. Let's take a look also at trees in general. This is not your problem. I'm going to do this one. Give me 2 minutes or 3 minutes for this one, and then I'll give you a couple minutes to do yours. So first of all, mine is just simpler. 3 red marbles, 6 blue marbles. What's the probability of getting a red marble? 3 out of 9. I'm going to simplify that to 1/3. What's the probability of drawing a blue marble?
6 out of 9.
6 out of 9. We'll simplify that to 2/3. Then I replace it. I put it back. If I drew a red one, what could I draw for the second draw? What?
Red or blue?
Red or blue? Everybody on board with that? So I have marbles in my little bag here, right? Red and blue marbles, red and white marbles in this case. I draw a marble. I put it back. I can again draw. I can get a red or blue the second draw. What's the probability I draw a red one?
1/3.
1/3. Right, 3 out of 9. Everybody on board? What's the probability I draw a blue one? 2/3. What if I draw a blue one first? For the second draw. So here's my marble. Instead of drawing a red one, I draw a blue one. In this case, a white one. Then I put it back. What can I draw for the second marble?
Red or blue?
Red or blue again. Everybody on board? What's the probability of red? What's the probability of blue? Good. And if I want to find the probability that, say, I drew a red first, then a blue, I just multiply along these probabilities. 1/3 times 2/3. 2/9. 2 times 1 is 2, 3 times 3 is 9. And here it is a little bit easier. Just multiply the probabilities as you go through here. 1/3 times 2/3, 2/9. So multiply the numerators, you multiply the denominators. This is how I like to look at it. So I need everyone's attention for like 30 seconds. Think of it like a river that's flowing. So you're flowing, you're in this river, and it branches. 1/3 goes to red, 2/3 goes to blue. You go towards red. So you're in this third of the river that's in red, and it branches again. 1/3 of it goes to a second red, 2/3 goes to blue. But that third that goes to red isn't 1/3 of the whole river. It's 1/3 of a third of the river, right? Because you already branched once before. So, are you guys following? So it's 1/3 of a third. It's less. Of means multiply. If I want 3 of these, and they're $100, I don't pay 3 plus 100. I pay 3 times 100, right? Of means multiply. So 1/3 of a third means 1/3 times 1/3. 1/3 times 1/3, which is 1/9. Does everybody follow me? How did I get here? It's 1/3 of 2/3. So 1/3 times 2/3, 2/9. Good? The other thing that's kind of cool, just to point out, and maybe I'll point it out on one of these slides instead, is that if you look at these, all of them, whenever they branch off from one spot, you always end up with something that equals 1. This 1/3 plus 2, that's 1. This adds up to 1, that adds up to 1. And also these guys here also have to add up to 1 as well. So it all came from the first initial beginning. All right, you guys, last thing you're going to do is lab problem 4. So do it quickly. You have literally 2 minutes to do it and 1 minute to go over it. So this one, you've got 6 blue, 3 red, 1 green, right? You're drawing a marble. What are your possibilities? Draw. Is there 1 in here? You're drawing 1 marble, what could you get?
7? Because
You're drawing 1 marble, what could you get? Red, green, or blue? Then you put it back, and you draw it again. What could you get?
Yeah, but there's still the total is yeah. It's just 7%. Because it can't be 18 out of 10.
No. And it can't be 20 because it's not 20.
Yeah.
What did you get? Oh, you're still. I'm horrible. I didn't even draw it. I just kind of went off of mental image. My bad.
So did you get 3 over 10?
Yeah.
I didn't even draw it.
Oh, you were fixing to stay and be there. Yeah.
So it's just like
So remember, we're putting it back. So even if I draw a green one, right, I draw a green one, I put it back, I could draw a green one again, in this case, because I'm replacing it. So I can draw a red marble, a green marble, or a blue marble. What's probably I draw a red one? 3 out of, not 3, 3 out of, right? 3 out of 10. Otherwise it's 300%. How about green?
1 out of 10.
1 out of 10. Blue?
6 out of 10.
Great. Now I put it back. If I drew a red one, what could I draw? What could happen next? Draw a red, a green, or a blue. Probability of the red. Green. Blue. Right, because I replaced it. What if I drew a green one first? So I draw a green one. If I can find it. I put it back. Now what can I draw? Red, green, or blue? Probability of red?
310.
Probability of green? Probability of blue?
610.
Great. And if I drew a blue one first and put them all back,
Same
same
thing.
thing could happen there. So let me ask you this. First thing is, what's the probability that I draw a red marble on the first draw?
3 out of 10.
3 out of 10. What's probably I don't draw a red marble?
7 out of
Yeah, the rest of them, right?
Same with
3 out of 10. Probably I don't draw a red on the first draw. There's 7 of them, right? 7 out of 10. And then the question is red then blue. So red then blue is this path here, red then blue. You're going to grab those two numbers and you're going to multiply them. 3 out of 10 times 6 out of 10, 18 out of 100. Make sense?
Can you go over B one more time, please?
Yeah, not red. What's not red? Green or blue. There's 7 of them out of 10.
On the second draw, wasn't it?
Oh, on the second draw. Right, so on the second draw, great. I replaced it. Same thing on the second draw. Doesn't matter what it is, because no matter what I did the first draw, I replaced the marble. Doesn't matter what. It doesn't matter what I drew the first draw. I replaced it. What's the probability of not getting a red? I have 6 white, 1 green. I have 7 out of 10 on the second draw.
Okay.
Good.
And if you were not to replace it, it would get a
Then it'd be a little more complicated. We'll talk about that next class. Ironically, it's actually the same.